Our learning goal today in this lesson is pretty basic. I can solve one-step inequalities in one variable using addition or subtraction. So it's pretty basic, but yet we have to make sure we understand especially how the inequality symbols work. That's where they get messed up more than anything. So when solving one-step inequalities, requiring the inverse operations of addition or subtraction, or in other words, you have to undo addition or you have to undo subtraction, the same rule applies as if you're solving equations. So you can have the same thought process that we had back in lesson 1.2 when we were solving one-step equations in one variable using addition or subtraction. So our first one here, what would we do to solve this then? If we have -6, what's that symbol say? Is greater than -2 plus x. What would be our move to get x along? Blake?
Add 2 to both sides of the...
Yeah, add 2 to both sides of the inequality. This time it's an inequality rather than an equation, right? Add 2 to both sides of the inequality. And what is -6 plus 2? -4 is greater than, these guys took care of each other, x is by itself now. There's our solution, right? Now, when it's written like that, you know, we talked about this yesterday. For some of us, when the variable is on the right side, that makes more sense to us than when the variable is on the left side. And others of us, we're just the opposite. Like, I like the variable on the left side rather than the right side. What does this really say? That -4 is greater than, -4 is greater than, we need to, you know, think in terms of what is it saying about the solution set. It is saying that -4 is greater than all the values x can be. So whatever you put in here for x, -4 better be greater than it. So give me an example of a number that would satisfy that. A number for x for which -4 would be greater than it. There aren't very many, you can't think of any? Presley? -5. How about -4? No, -4 is not greater than itself, and it doesn't say it can be equal to itself, right? So, but what if we turn it around? Remember, we can always flip an inequality statement and we can have it so it reads the other direction. So this inequality statement can flip around and become x is less than, so the sign changes direction, -4. So now it's saying that all the numbers x can be, so now we're reading it saying, okay, all the numbers x can be are less than -4. All the numbers x can be, whatever you choose for x, has to be less than -4. So, is -5 still qualified? Is -5 less than -4? Yes. Still qualified. So no matter which way we read it, the numbers that we choose for our solution set have to satisfy it. So we're going to put -4 as our endpoint. And then integer neighbor over here is -3. Integer neighbor over here is -5. Now trust me, just, you know, you guys, these are easy to solve, but here's where students mess up when I'm correcting quizzes. They can't make the number line for me. They cannot show the solution on a graph either properly or, you know, it's either they don't understand the inequality symbol or they don't have good number line sense. So it's really important that you pay really close attention to making sure. This is probably more important. Can you show what that solution means? So would we have an open or closed circle at -4? Open. Open. And then we decided that -5 satisfies it no matter which way it's written, right? So would we shade this way? Yeah. -3, would it satisfy it? Is -3 less than -4? No. Is -4 greater than -3? No. So either way we read it, it doesn't make sense. Okay? It doesn't satisfy it. Now, I am not going to make you do check problems, but here's the deal. You should be able to check something, even if you're doing it with mental math. you should check them. Because lots of you are, you know what? You're scoring on these assessments like you really, all that matters is just to do it and get it done. And if you just took the time to check it, you'd probably catch some silly mistakes that you're making. So if we're going to check, when we check an inequality, now you need to listen carefully to this because I don't want you to think that we're checking to see if -4 is a solution. The first thing we're going to do is we're going to replace the inequality symbol with an equal sign. So we're going to take our inequality, which is, it starts as -6, am I right? And we're going to make it equal to -2 plus x. We're going to check the endpoint. So we're checking right now, why don't you put this here, we're checking -4. We say that -4 is like our starting point. Whether it's included or not, we just need to make sure we're at the right location on the number line. So we're checking right now to see if we're at the right location that we're working out from, whether we're working this way or we're working the other way. So now we'll put our -4 in for x. We're not solving, we're checking, we're substituting in and evaluating. So we say, well, -6 doesn't have anything to be combined with. What is -2 plus -4? It actually is -6. So we could say our endpoint checks. In other words, we're not checking to see if it's a solution. We're not checking to see if it's a solution. Because is it? No. We have an open circle at it, don't we? It's not a solution, but we want to make sure we're at the right location on the number line. Because we could very easily have ended up with a +4, and we would not be at the right location. So then when in step B it says that we are going to check a number, so now we're going to check a number from the shaded region in our inequality. Okay, we're not going to work with an equation anymore. Now we want to make sure that we shaded the correct side of this endpoint. So what do you suppose we could check? What's the number that you said works? You think works anyway? -5, right? So let's check -5 out. Let's make sure we shaded going the right direction. So -6 is greater than, is that how this symbol goes? Am I right? -2 plus x. So our original inequality, we'll substitute into it our -5 for our x. Well, -6 doesn't have anything to be combined with, is greater than. What is -2 plus -7? -5. Wonder what it is. Yeah, I bet it's -7. Okay, true or false statement?
True.
So what does it say?
-6 is greater than -7.
And that's true, isn't it? So our shaded region checks. So we just found out that, you know what, we're feeling pretty good about the whole thing. The only thing that possibly might go wrong in this one is I shaded in the endpoint when I shouldn't have. Because in this one, what kept us from shading in the endpoint? What no matter, before we even solve it, we can look and say, I know my endpoint's not going to be shaded in because why? There's no line under here. There's no equal to bar, is there? So we don't have an equal to part to satisfy. We only have the is greater than to satisfy. So we do not, we right away know before we even solve that we better not shade in our endpoint. Okay? So again, I am not saying that you need to do check problems in your homework, but we better know how to do check problems. So if I drop a 50-point quiz on you right after break, one problem to solve, and you have to get every part of it right to get 50 points or you get a 0. Would you want to make sure you're right? Would you want to make sure you didn't make any silly mistakes? Like -6 plus 2 is +4. And but that's all it would take. Is one, and if you don't take the time to check it, then you don't know. Okay, questions on this side at all? Let's go back. You go ahead and solve number 2 and graph it. Solve it and graph it. No, there's not enough room for you to check it, so you can do a mental math check if you want. So When you're done, will you check me out, see if I have the right solution? Do you like my solution? Yeah. I'm starting to graph it. Do you like what I'm doing? Got my integer neighbors, right? What's wrong, Lori?
The 3 and 4 are equally. The 3 should be closer to 3.3 because 3.3 is in the middle of 3 and 4.
So 3.3, here's what your habit's going to become. Stick a tick mark, put the endpoint there, put some tick marks on either side of it. Who cares? Throw the integer neighbor here, throw the integer neighbor here, graph it, and be done. And would I be showing good number line sense here? No, like Corey said, should 3.3 be about halfway between those two? In fact, I want you to tell me approximately what fraction is 0.3 closest to. Not halfway, it's not closest to 1/2. What is it closest to, Blake?
3 1/3.
Yeah, it's more like 1/3, isn't it? It's 3 and 1/3 because 0.3 repeating is 1/3, and this is 0.3. Lots of people like to round 1/3 to 0.3, but in reality, it's, when you're rounding, I guess that's okay, but it's really 3.3 repeating. So we're saying this is closer to 3 1/3, so I should be about 1/3 of the way over, not halfway over, right? So again, we don't have to get out a ruler and make sure that it's exactly, but we have to show some sort of number line sense here. Shade in the circle or not?
Yes.
Okay. Does 3 satisfy it? Is 3 greater than 3 3/10? No. How about 4?
Yes.
Okay, so then I need to shade this way, right? Okay. Now, I tend not to say, because this is what happens when we do that. I tend not to say, oh, when it is greater than, shade to the right, when it is less than, shade to the left, because you know what? Sometimes we might not be saying what the symbol is saying correctly anyway. I want you, instead of, or we maybe, starting tomorrow, we might have needed to reverse the symbol and we didn't. So it's better to say, does this make it true or does that one make it true? That's why we're putting those integer neighbors there. Okay, let's go on to our next one here, where we're going to describe our variable, set up our own inequality, and show the solution also as a graph. So go ahead and read that to yourself. Maybe underlining, circling, picking out important pieces of information. You're doing this. Oh, are you ready?
Yeah.
Oh, I got kind of sidetracked there, sorry. Okay, so what's some important information in this? Maddie?
The maximum load is at 1 ton.
Maximum load 1 ton, okay. Some other important information in this. Anything that you think might be useful? Rachel?
The crate weight of W.
Great weight of W pounds. Oh, look at there. They already tell us what the variable is going to be, so we're going to write this down. W is the crate weight. Okay, so in our problem, because we always have to describe the variable that is in our setup. So W is going to be the crate weight. Well, they already took care of that for us. Thank you. Okay, now, is there anything else that is important in this? Is there just a crate on the elevator? Corey?
Passengers on the elevator.
Okay, so the total weight of passengers is 1,400 pounds. That's kind of important to know. They're on the elevator. Okay, Parker?
Plus the delivery man weighs 243 pounds.
Oh, and then we got this delivery man who weighs 243 pounds, and he comes on the elevator also. Okay. Anything else? I think there's probably still some kind of important information that's going to help us set up the relationship here, because this is not going to be an equation. Parker?
It must not exceed 1 ton.
Not exceed the weight limit, which back up here is 1 ton, right? Okay, well, so we got all kinds of stuff there. Is there anything else that we need to take into account in here? And I hope your thought isn't this, well, there's no more numbers left. Because do they ever throw in numbers that we don't need to use? They do, but we tend to think we have to use everything in a word problem just because it's there. So they would have said, in 2004, April 5th, 2014, or in the year 2014, and then we think, well, then that's got to be in there somewhere. No, they're just, setting up the scene for us, I guess, okay? So go ahead and write an inequality statement that will represent all that stuff that we said is important here. Write an inequality statement, which would mean it doesn't have an equal sign in it because it's not an equation. It should have an inequality symbol. And I'm going to say 1 of 4. Not is not equal to 1. So now you get to use numbers and symbols and variables, and you don't have to have any words in here. No, you have an inequality solution, but you don't have an inequality statement to start us out. Don't do any arithmetic, don't do any simplifying, don't do any solving, just set up the statement that represents this. Okay, who's going to share theirs with us? So you do the one more time again. Okay, thanks, Corey.
1400 plus 243 plus W is less than or equal to 2000.
Trying to keep up here. Is that what I heard?
Yeah.
Okay. So here's what this tells me, without me looking above at anything. This tells me that there's 1,400 pounds on the elevator, plus another 243 pounds on the elevator, plus another W pounds on the elevator, and it can't weigh any more than, but it can weigh up to 2,000 pounds. But is that true? You guys agree? Where's the 1 ton? Where'd the 2,000 come from? Blake?
There's 2,000 pounds in 1 ton.
Yeah, so this probably gave us the information. We got tons going on, we got pounds going on, we got one or the other. So you either turn the total weight of the passengers on this elevator into tons, and the weight of that delivery man into tons, and the weight of that crate into tons, which sure sounds like a whole lot of work. Or you're going to change the ton into pounds, which sounds like a whole lot easier, right? Okay, so I think this is a good setup. The total weight in the elevator has to be 2,000 pounds or less. Go ahead and solve that now. I get that this crate can weigh 357 pounds or less. Do you agree? Okay. Well, remember though, when we know what the variable is representing, we have to decide that any restrictions or anything that, like that really can't be. So we got, remember W is the weight of the crate. Is there anything, remember it starts at 357 and it goes that way. The number's less than 357. So when we think about going that way, is there a stop point, or can it just keep going?
0.
0, because we don't have negative weight, do we? Okay. So non-negative, W is non-negative, or we could say it's positive, I guess either way it means the same thing, right? But when we say non-negative, basically we're saying that we are in 0, it can be 0. Well, that's kind of questionable in this one. I'm not really sure, that's a toss-up. If the delivery man went on the elevator with a crate, it has to have some weight, right? Yeah, but if the delivery man sees all those people on there and gets scared, doesn't take the crate on, and just goes on himself, then, but, yeah. So we're gonna, so we can maybe write that as positive also, because weight is not measured in negative values, okay? Something can have a 0 weight though, can't it? But it's really non-existent if it has a 0 weight. So we're going to put our 357 on here, and should we shade in our circle? Yeah, because remember that's W, so W can be, the weight can be 357. But now that we've defined it and said it can't be negative, it's going to have to stop here at 0, you said. And we're going to actually leave that circle open because we're going to assume that the crate's definitely going to go on the elevator with the guy, and it has to weigh something, right? And so in between, we would shade, okay? So again, when we know what the variables are representing, sometimes there are restrictions, other times there isn't. We can have negative temperature, we can have negative profit, we can have, we can have things like that, but we can't have negative weight. Okay, anybody have anything you want to talk about anymore with that before we go on to our critical thinking challenge you problems? Okay, you're going to do something like this in your homework also, so we don't just count on my brain here, count on yours too, okay? Here's the deal, it says, use the inequality, circle this, x minus 4 is less than 10. Use that inequality. Look at this team that's going to work together here. It says to complete the following inequality statements. So here's our inequality statement that has to be completed being related to that. So that's the only thing we have to really start with. So we're just going to write that down first. We're going to say, how could I rename that? What could I do to that that would get me to that? Any suggestions? What could we do to x minus 4 is less than 10? To rename it so that x is by itself. This is the easy one. Come on.
Add 4.
Add 4. Add 4. Then x will be by itself. So we're going to have x by itself now, because these guys take care of each other, is less than, what? 14. So our fill-in-the-blank answer in this one is 14. Now, we have a second inequality. In other words, a new name for this one. So we now really have another inequality that we could work with if we wanted to. Okay? Because now we're going to move on to this one, and it says x minus 14 is less than something. We got to fill in the blank. So we have two options here. We could either start with x minus 4 is less than 10, that name, or we could start with the other new name that we just came up with, x is less than 14. Go ahead, you try something. You pick whichever one you want and try something. Figure out what the fill-in-the-blank answer is for this one. We're going to come up with a third name for this inequality, in other words. X minus 14 is less than something. Okay, who wants to offer which equation they use that's done? Rachel, which equation did you use? Which name?
I used x less than 14.
Okay, x is less than 14. Okay. And then what'd you do?
I subtracted 14 to get 14 on the same side as x.
Oh, because we need to subtract 14 from x, it says, and that x was by itself, so if we subtract 14 from both sides, we will have x take away 14 over here, and is less than, what's 14 take away 14? 0. So it appears that the fill-in-the-blank answer is 0. Well, I'm convinced that we could use the other one also. What could I do to that one? I better get the same answer, because remember, they're just names for each other, so they're not their team here. Corey?
Subtract 10 from the answer.
I could subtract 10, because if I subtracted 10 from 4, what would I get? Negative 14. So I would have x minus 14 like I want. And, oh, that's kind of funny, 14. And, but if I do that on this side, I also have to do it on the other side, don't I? So 10 take away 10 is 0. We get the same answer, don't we? It doesn't matter which name we work with. Well, now we have a third name for this inequality. So go ahead, you do C now. You got 3 choices. You can pick any of those to start with. Use it to help you get the fill in the blank for an x plus something is supposed to be less than 16. Just do it. Yeah, just pick one and start, kind of like we did here. So we started, in this one, we started with this name. In this one, we tried each of the other names. And now we have all 3 possibilities. This one, and that one. Let's do C. Anybody get anything to happen yet? Anybody think they know the right answer? X plus what? Like, what do you think it is? 30. 30? Okay. Anybody agree with me yet? This is 30. This is the wrong one. Do you want to agree with them? Okay. Well, they're not ready.
Thanks.
Keep trying. Not 30. Sorry. And you're gonna have to do this in your homework, and I don't want you to give it up easily and just put pencil marks on your paper. I want you to think. Anybody got it yet? Okay, I think part of the problem is that you're concentrating on the wrong side this time. Concentrate on this side. You need to get that side to become 16. So in this one, that side is what? 10. In this one, that side is? In this one, that side is? You need to make that side become 16. Do it. You can. Not hard. Think about getting that side to be 16. And then whatever you have to do to that side, you make sure you do to the other side. Homework. Trust me. We'll all get the same answer eventually. Richard, pick an equation for me. Which one did you use? X minus 4 what? Which inequality? Did I say equation? I think I did, didn't I? Inequality. Which inequality did you use? Okay. Well, Richard, did you do anything to that? No, you're hoping it'll do it to itself. Huh? Well, how can we get that 10 to become a 16, class? Add 6, yeah. Let's just add 6 to that. See, this isn't hard. Come on. We could do this. X, what's minus 4 plus 6? Plus 2. What's 10 plus 6? Why, looky there. Huh. Anybody use a different one? Rachel?
I used x minus 14 is less than 0.
And what do we have to do to that one?
I added 14 to 0.
add 14 to 0, because you wanted to get that
X by itself.
x by itself, okay, go ahead.
I added 2 to both sides.
Because, well then, I don't know why you didn't
And
just,
you get 16.
I don't know why you didn't just start with this one in the first place then, right? But anyway, then you would add 2 because that would get 16, and sure enough, x plus 2 is less than 16.
Oh my gosh.
That was impossible.
It still is.
That's hard?
Yeah.
Okay, why you just like
That's
get random numbers, like, oh, I want 2 here.
I think this is college.
Yes, welcome to college. But it's free, but this is free college, that's the best part.
Oh, yeah.
Yeah, because Miss Gilbreth, college costs a lot of money, right? This is free.
Yeah, that's how I was looking at it, I'm like, 14 gets 16.
Oh gosh, so you know what Rachel could have done here when she says if that she can use this one, instead of adding 14, she could have just added 16. Because 0 plus 16 is 16, and then over here we would have had x plus 16, or x plus 2, I mean. Negative 14 plus 16 is 2. Oh gosh, it just really isn't. We just have to, oh, you know what the problem is? We just are
We're
not
just too
used to
smart for
thinking.
I
this.
think you just throw random numbers.
Okay, let's get started on your homework, because I'm exhausted.
You're exhausted? What did you do?
I'm exhausted.
Oh, Josh.
Did you just ask what it time?
We were the ones spinning our heads.
I'm not sure if you were though. That's